And LC site control on countdown 1.
Yeah, go ahead, site control.
And pre-pullback is complete.
Okay, copy that. And Marcel, can I get you to give me step 334?
And LC Marcel is configured to pre-pullback.
All right, copy all. Okay, launch team. So we've accomplished important part of today's operation was just to make sure that we didn't have our harnesses hung up in a bad position from yesterday's scrub attempt. And so we already have the tail now in our pre-pullback position. Today, when we go ahead and begin our propellant loading operations, we'll be skipping through those first few steps where we're pulling desiccants and getting into that position, and then going straight and waiting for our low-flow RP loading start. So good job, team. And we're going to go ahead and return back to into our range and facility setup at this time.
LC, this is Elect 1. Battery cell voltages are nominal.
Okay, Elect 1, copy. Battery cells are nominal.
And LC Ops 2,
that'll give us step 43.
LC Ops 2, 42 is complete.
Okay, copy that. Ops 2, we'll check 42 complete as well. And FAA, this is LC on countdown 1 for a comm check. And FAA, LC, countdown 1 for voice check.
This is the FAA on countdown 1. That reads you loud and clear, how many?
And FAA, loud and clear as well. Good morning, and we can go ahead and check step 6 complete.
FAA copies.
Okay, site control, LC, countdown 1. And site control, LC on countdown 1. Site control, LC, countdown 1.
And this is site control, go ahead.
Yeah, site control. As we're back in our range and facility setup, normally we would be going ahead and kicking off the charging of the tail rapid retract system. Are we ready to begin that at this time?
And A-firm, we can go ahead and begin that.
Okay, so you go to charge the tail rapid retract again throughout the countdown. If you need to re-perform that that series of steps, you are go for that without requiring any LC confirmation on that.
And copy. I'll go ahead and get that in work.
Okay, roger that. I'll wait for your call back.
LC, OPM, countdown 1.
Yeah, OPM LC countdown 1, go ahead.
Yeah, I'm tracking a hard stop on our DAS out here at 01:27 hours. I believe that's for the vehicle power-up. I just wanted to verify that if we have a 400-foot clear in place for that, that we'll be able to re-enter the pad after power-up, because Mars was delayed in doing some of their activities because of this early pre-pullback.
Yeah, so understand the situation, OPM. We have a couple of options here, but is there a way you can get an estimate from how much more time Mars needs to close out the pad work?
Yeah, I inquired about that. They're not sure. I think they may need possibly another 30 minutes after that time.
So they need They need 1 hour at this time. They have an additional hour of work to perform at this time.
At this time, the estimate is they have less than an hour's worth of work to go.
Okay, copy that. So we'll just keep pressing, and when we get to the Antares power-up, which is when we need to do the 400-foot clear, we'll check back with you guys, see where you're at and how much more time you guys need, and then if we have to, we'll delay the power-up, or we'll get you guys to pull back, get the power-up going, and then get you guys back in.
OPM copies. Thank you.
LCA.
Well, good evening, everyone, and welcome here to the launch pad, or maybe good afternoon or good morning, depending where you're joining us from. Welcome to our live launch coverage of Cygnus CRS-2 NG-18, also known as SS Sally Ride, a cargo resupply Cygnus craft heading up to the International Space Station. This is night 2 of our launch coverage for the Cygnus, as last night the launch was scrubbed. There was a fire alarm in mission control, which turned out to be a false alarm. So they reset, and we're going to go for it here again. We are now counting down L-4 hours, 10 minutes and counting. We've patched in the mission control net, so we are listening into them. So I'll pause anytime we hear them come back on the net there. Heading up to the International Space Station, this is the last Antares 230 plus rocket. The next one...
Site control, or LC site control, ECS dryers confirmed on.
Copy site control.
The next time we see another rocket like this out of Wallops will actually be a new updated Antares in partnership with, I believe it was Firefly, to help continue bringing these programs together. You're looking at a live view of LP-0A at the Wallops Flight Facility in Virginia, USA, with the Cygnus craft on top of the Antares 230 plus rocket heading up for NASA. This is the 17th launch of any Antares vehicle of any variant, and the 12th launch of the Antares 230 rocket. This will be the 19th launch of the Cygnus spacecraft, and the 7th to launch on a 230 plus. We are now at the 154th orbital launch attempt of 2022, and we want to hear from you guys in the chat. How high do you think that numbers go? Let us know what your guess is for the end of the year. We got just under 2 months left.
Okay, launch team steps 245, 246, and 247 are not required.
2 months left, so let us know what that number is. If you haven't yet, take a moment, engage that like button, really does help us out. And if you're new, welcome. Consider engaging that subscribe button so you never miss another live launch coverage, space briefing, space news update, or exclusive one-on-one interview right here on the launch pad.
LC on countdown 1.
Admin, countdown 1.
Step 248, enter flight timeline into OCCS.
Admin, flight timeline entered.
Admin, arm sequencer engine start.
LC admin, sequencer engine start armed.
And LC properly file verified as flight OCCS timeline. Pad configuration has been briefed to the loading team. Mate monitor checks have been complete and set. OCCS is in manual mode. All screens are active. Step 254, switch configuration verified. All PHS switches enabled. Deskant hoses are not installed. Post O1 F1 algorithms are active.
Copy all. Prop lead and core 1, LC on countdown 1.
Go ahead.
Yeah, core 1 report values of N for O1 and F1 tanks.
For O1, got an N level of 16 of 17. For F1, an N level of 11 of 17.
And core 1 direct Fusionoia to initiate FMS to input N levels into OCCS and report when complete.
Copy and work.
And launch team steps 260 through 272 are not required. Prop 1, LC on countdown 1.
LC prop 1, go ahead.
Yeah, step Whiskey 1, verify FMS sawtooth active.
FMS sawtooth verified active.
Prop 1, send OCCS Lowell's initial state command.
Didn't work. All's initial state command sent.
And Prop 1 LC on countdown 1, Whiskey 3, reconfigure LO2 ground system for launch vehicle interface purge.
Copy and work.
Prop 2 LC on countdown 1, Whiskey 6, send OCCS, HSS, and RP1 initial state commands.
LC Prop 2, that's in work.
LC Prop 1, Whiskey 3, locks ground system reconfigured.
Copy Prop 1, your go for Whiskey 4.
Opening 4070 on my mark. 2, 1, mark.
LC Prop 2, HSS initial state command is sent. RP1 initial state command is sent.
Copy Prop 2.
LC Prop 1, Whiskey 4, LO2 LV interface pressurized.
Copy Prop 1 and Prop 1 configure valve 4089 and 5010 to initial state.
Copy and work. LC Prop 1, Whiskey 5, 4089 and 5015 configured for initial state.
Copy Prop 1, check steps through Whiskey 6. Prop 1, verify or resume all OCCS server auto sequence controls.
OCCS server auto sequence controls resumed.
And verify or resume all OCCS control loops are running.
And all control loops running with the exception of LN2 subcooler fill, which Mars still needs paused.
Copy Prop 1. Prop 1, stop post O1 algorithms.
And work.
Prop 2, stop post F1 algorithms.
LC Prop 2, it's in work.
LC Prop 1, PHS post O1 algorithms halted.
LC site control training on countdown 1.
Go ahead, site control training.
Step 49, tail rapid retract is charged and reporting that equalization of pressures is not required. Step 50 is NR.
Copy that, site control training.
LC Prop 2, PHS post F1 algorithms halted.
GCE LC on countdown 1.
Go ahead, LC.
Yeah, step Whiskey 11, provide direction on HPGN2 circuit configuration.
I believe we will be on primary, but they're still doing some setup, so it might take us a little bit to get there.
Okay, copy that. And GCELC on countdown 1.
Yeah, go for GC.
Yeah, based on our BACnet discussions, we'll go with secondary on the HPGN2. If we need to switch it, we can do it per our appendix.
Affirmative.
And Whiskey 12 is not required. And Whiskey 13 is complete. Prop 1, place OCCS into semi-auto mode and arm OCCS for O1 F1 tank desiccant hoses not installed.
In work.
LC, Core 1 on countdown 1.
Go ahead, Core 1.
I've got step 257 for you. In levels inputted into OCCS.
Copy that, Core 1. And prop lead LC on countdown 1.
Go for prop lead.
Yeah, can you cover step 258, verify N levels in OCCS?
N levels verified at 16 and 11.
Go ahead. Prop 1, OCCS, ACDC, arm.
Copy prop 1, check step Whiskey 14.
ACDC confirmed.
Copy prop lead.
And LC Prop 1, OCCS configured for O1 F1 tank desiccant hoses not installed.
And prop lead. Step 259, perform PHS EPV electrical test.
For a second attempt, that's verification only, and that is complete. EPV check's complete.
And GCE Whiskey 17, provide direction on warm helium circuit configuration. GCE LC on countdown 1.
GC on countdown 1.
Yeah, GCE Step Whiskey 17, provide direction on warm helium circuit configuration.
And warm helium will be on primary, which it is.
LC copies. Check Step Whiskey 17. Whiskey 18 is complete and Whiskey 19 is not required. Prop 1, your go to transition OCCS to auto mode.
Copy. That's correct. LN2 is still paused, so we cannot go into auto sequence. We can stay in semi-auto. LN2 resumed. OCCS in auto mode.
All right, this completes Appendix Whiskey. And site control, Step 51, read back Stage 1 ECS operating parameters.
And LC site control, core ECU temperature, core ECU 1 temperature set point is 95 degrees Fahrenheit. Core ECU 1 flow rate is 2100 CFM. And core ECU 2 temperature set point is 95 degrees Fahrenheit. And core ECU 2 flow rate is 2100 CFM. And interstage bay flow rate is 880 CFM. Inner tank bay flow rate is 920 CFM. And aft bay flow rate is 1700 CFM.
And Stage 1 MEC, LC on countdown 1. Verify Stage 1 ECS parameters are nominal.
LC, Stage 1 MEC, Stage 1 ECS, nominal.
And system, verify ECS parameters are nominal.
LC system, yep, payload ECS parameters are nominal.
Site control, can I get the ECS parameters on the payload for documentation purposes?
And the temperature set point for the payload ECU is 56 degrees Fahrenheit. The payload ECU humidity is 10%. And the payload ECU flow rate is set to 1815 CFM.
And Core 1, verify MSGE is configured to support loading operations.
LC, this is Core 1, that's affirm, also for FMSGE.
Copy, check steps 55 and 56. OPM provides status of LEV doors.
This is OPM. LEV doors are secure.
Site control, confirm LEV pressurization fan.
And pressurization fan confirmed on. And the shutout valves are still locally set.
And LC, GCE on countdown 1.
Go ahead, GCE.
Just want to make sure you're aware that the LEV doors, the internal doors are open between the two LEVs as they were yesterday. The external door is closed.
LC copies. GCE verify HSSG and 2 charging configured for 843.
HSS charging is configured for 843.
And GCE, verify catch tank is drained.
Catch tank is drained.
Step 273, management on station voice checks. CMD. LC on countdown 1 for voice checks.
LC, this is CMD. I hear you loud and clear. Help me.
Loud and clear. LD.
LC, this is LD on countdown 1. How do you read?
Loud and clear, LD. NG.
LC, this is NG. Have you loud and clear? How me?
Loud and clear. Admin, input and confirm OCCS sequencer initiation time.
LC admin, I have sequencer initialization time as 2022, 3:11 hours 06 minutes 47 seconds 43.0.
And Core 1, direct Ujinoya to start first MS session at L-3 hours and 52 minutes and report when completed.
LC Core 1 copies and work.
And Prop 2, Step 277, turn on heater 5181 and 5182.
277 is not required.
Copy, Prop Lead.
LC, this is admin. I may have missed the call. Was that a good read on that sequencer initialization time?
Yep, sorry, admin, I've got that loud and clear. Thank you. Okay, launch team, sequencer initiation time will be 6:47:43 Zulu. Target T0 launch time is 10:27:43. At this time, I'd like to poll to initiate the loading timeline sequencer, Step 278. Mars site.
Mars site is go.
GSO.
GSO go.
NASA TD.
TD's go.
Safety.
Safety's go.
Prop lead.
Prop lead is go.
Stage 1.
Stage 1 is go.
GCE.
GCE's go.
ACE.
ACE is go.
Go for sequencer startup. Elwo. LC on countdown 1.
LC, this is Elwell on countdown 1.
Yeah, we're ready for your weather brief.
Okay, copy that. This is Elwell on countdown 1 with this evening's first weather briefing for NG18. We are looking at similar conditions from what we saw last night. We still have this stationary frontal boundary off to our west. and southerly flow out ahead of that front that is providing us with some low-level moisture and the potential for some stratus clouds to develop at the lower levels of the atmosphere as we go through the evening tonight. Currently, we're just seeing a few clouds at around 6,000 feet with unrestricted visibilities or winds out of a south-southwest wind direction at around 6 to 12 knots, and our temperature holding in the mid-60s this evening. Off the coast, our Wallops buoy reading at 3.6 feet. I want to take a look at our satellite imagery and what we're seeing currently with this cloud deck starting to approach the region from the north and from the west. As you can see, it's starting to break up a bit as it comes over, and that is what the models are indicating that we're going to continue to see over the next few hours as this continue to move off to the east and break up just a little bit more than what it is currently. So not expecting a solid deck of low clouds. We're dealing with a height level at around 6,000 feet, which is just under our sky screen criteria, so that is something that we'll be watching to ensure that we do not violate that sky screen limit of 6,300 feet. Looking at our computer model simulation and what we expect over the course of the next several hours here, we will see a few showers developing across the northern Virginia area here in a few hours, and it looks like that will all stay off to the north and west. So by the time we get to T0, we should not see any shower activity anywhere in the vicinity of Wallops, and all of that shower activity will be very light and off to the north. So no issues expected there with any kind of precipitation or thick clouds, which we thought may have a shot at violating some of our constraints as we were looking at things yesterday. It looks like that thick cloud rule is becoming less and less of a concern as we go through the last few hours and get updates on current weather conditions expected for T0. So for our model simulation here with clouds, you can see over the next few hours things begin to increase a bit with the clouds as they move in from the northwest, but we are looking at a fair amount of cloud breaks within that as they move off from the north and west. So not really looking at a major concern there as it moves across the region here over the next few hours. Looking at our upper level wind data, very similar conditions from last night in the upper levels as far as wind speeds go, maxing out around 50 knots at the 50,000 foot level. We are seeing a little bit more of a westerly component in the atmosphere though as we go up in height, and see that westerly component pretty much hold steady as we get up to around the 60,000 foot level. At the surface, expecting those winds to be more out of a south-southwesterly direction for the first couple of thousand feet before picking up that westerly component. Comparing the next several hours of what we're seeing from our models, you can see the line's pretty tightly compacted here on this simulation, indicating that our wind speeds will not really be changing that much from where we are now to what we'll see at T0. Looking at our countdown forecast, expecting a few clouds right around 4,000 feet during the countdown. Also some decks around 6,000 feet will be possible at times. Very slight chance that we will see those cloud decks become broken. But again, most of that cloudiness is going to see some breaks in it, and we'll see the cloud ceilings generally in that 6,000 to 7,000 foot level as we get closer to T0. Wind directions out of the south-southwest at 7 to 12 knots. Temperatures in the mid-60s expected, and our relative humidity expected mid-80s to around 90%. Launch forecast, again, could see a scatter deck at 4,000 feet. We're starting to get some indication that maybe these clouds are a little higher than what the computer models are showing as well. So seeing some 6,000 to 7,000 foot level cloud bases, which will be better than the 4,000 feet, as we do see that sky screen limit at around 6,300 feet. So looking overall pretty good for our launch window here at Wallops, with our winds holding steady out of the southwest at around 7 to 12 knots. And Bermuda weather, very similar to last night. They're seeing some wind gusts up around 25 to 30 knots, once again with some scattered showers out over Bermuda tonight as well. Looking at our summary of launch constraints here for weather, we are currently green for weather, and only holding about a 20% chance of violating that cloud ceiling limit for sky screens at 6,300 feet. not really expecting much potential for patchy fog. So really the only thing we'll be monitoring is making sure that these sky screens are not violated as we go to T0. Our last update yesterday after our launch scrub was probability of violation of 30%. And as you can see, we've dropped that for our briefing here to 20%. So the trend is in the right direction, and we're hoping with our next briefing we'll be able to drop that a little more. But right now, 20% probability of violating weather constraints at T0. That'll conclude my weather briefing. Any questions?
Well, Stage 1 mechanical. How do our surface winds look out to about T plus 2 hours?
Yes. So after we get to the T0 time, we're looking at winds pretty much holding a steady 7 to 12 knot wind speed. The only difference in our winds at T plus 2 hours is they'll see more of a westerly component, but still around 7 to 12 knots. As we push past the 2 hour limit, as we get to about 18 UTC this afternoon, we'll start to see the winds pick up a little bit out of the northwest, maybe up to around 10 to 15 knots, but overall fairly steady winds even through the afternoon today.
Copy, thank you.
All right. Thank you, Elwo. I can confirm OCCS sequencer startup.
LC Core 1 on countdown 1.
Go ahead, Core 1.
I step 275 for you. The first MS session has started.
Copy, Core 1. TLM, your go for 276.
Copy and work.
And step 280, place the dynamic limit checker in automatic mode. TLM. Sorry, stand by on 280. Ops 1, step 63, verify aura and SA status.
LC Ops 1, aura and SNA status verified nominal.
And Ops 1, verify plugs, helium emergency vent, and UMBI SEP loop status.
LC Ops 1, plugs, helium emergency vent, and UMBI SEP loop status verified nominal.
Ops 1, verify battery charge enable status.
Battery charge enable status verified nominal.
Verify pad J-box and tower J-box pressure is on.
LC Ops 1, pad J-box and tower J-box pressure verified on.
Perform helium vent enable test.
Copy and work. LC Ops 1, helium vent enable test nominal.
And Ops 1, disable helium vent enable and report status.
Copy and work. LC Ops 1, helium vent enabled, disabled, and nominal.
And step 69, verify no additional activities requested of personnel at launch pad. GCE?
GCE, no expected additional activities.
Core 1.
Actually, sorry, LC, GCE.
Go ahead, GCE.
I forgot. We do have to reset the regs for the heated GN2 circuit after we, when we can get back in.
Okay, copy GCE. And Core 1?
Go ahead, LC.
Yeah, step 69, verify no additional activities requested of personnel at launch pad.
Yeah, Core 1 confirms.
And Mars site?
Mars site concurs with GCE. That one rig has to be set.
LC copies. OPM verify pad configuration is complete and ready to support launch operations, sans this high-pressure GN2 regulator.
That's a firm pad configuration is complete, less the item already pointed out by GCE.
And TLM, LC on countdown 1.
Go ahead, LC.
Can I get a status on step 276?
So step 276 is contingent on the vehicle being powered up. So we are waiting on 276 until avionics is powered up, and we communicated with Core 1 to look at their needs in relation to vehicle power.
Okay, copy that. OPM, step 71, evacuate launch site to initial fallback area.
Personnel are clear of the vehicle and launch site is evacuated.
GSO, announce evacuation of launch site on public address VoiceNet and report when launch site is clear of personnel.
And work.
LC GSO, check items 72 and 73.
LC copies. Step 74, verify dynamic limit checker in phase 1. TLM.
LC TLM, DLC in phase 1 in the MCC room 117.
Core 2.
LC Core 2 DLC in phase 1 in E100 for National breakout room.
MES2.
LC MES2, DLC in phase 1 in the cab.
And Chimon.
LC, this is Chimon, DLC in phase 1.
Check all steps through 74. Step 75, TLM at DCOM setup telemetry archive.
Copy and work. LC, TLM, the archive file name when you're ready.
Ready.
2022 11 07 underscore 861 underscore 1 underscore NG18 underscore launch underscore P as in Papa underscore 2.
And we're ready to poll for launch vehicle external power on Mars CE.
Ed, LC Mars CE, Mars go.
GSO.
GSO go.
RSO.
RSO go.
NASA TD.
TD's go.
Ops 1.
Ops 1 go.
Ops 2.
Ops 2 go.
Elec 1.
Elec 1 is go.
GCE.
GC's go.
ACE.
ACE's go.
TLM, start G2 recorder and read back system time.
In work. LC, TLM, recorder started, and time when you're ready.
Ready.
2022, 311, 06, 56, 19er.
And TLM, start MCC TDS distributor logging. Split the GTLM log and verify logging to intended directory.
In work. LC, TLM, logging started and split, verified logging to correct directory.
And Ops 1, verify failsafe panel indicates all safe.
LC Ops 1, all safe illuminated.
Red team lead, be advised external power being applied to vehicle. Verify all personnel 400 foot clear of launch pad until further notice.
Copy and confirm clear.
Ops 1, apply external power to systems as listed.
Copy. Avionics encoder, RF switch, external power on. Flight computer, external power on. Standby 20. Motor cone encoder, external power on. Stage 1 encoder, external power on. Ground mock, external power on.
TLM, verify lock on data streams and start telemetry archive.
In work. LC, TLM, lock verified on data streams, archive started.
And LC prop lead on countdown 1, start of lowest showdown.
Copy, prop lead. Check step 284. Ops 1, continue applying external power to systems as listed.
LC Ops 1, copy. Main engine encoder alpha, external power on. Stage 1 controller, HC 1700, external power on. ACM, external power on. Instrumentation, external power on. ME-B, external power on. OrbNav, HG 9848, external power on.
Analec 1, verify all mocks are synced to PTP server.
Copy and work. LC, this is Lec 1, all mocks sync to the PTP server.
Copy Lec 1. Ops 1, apply external power to remaining systems.
Copy. Stage 2 ECU, external power on. Storm, pressure transducer, external power on. SMI power A, B will come on also, external power on. LC Ops 1, all external power nominal.
Analec 1, step 87, verify external power parameters are nominal.
LC, this is Lec 1, external power parameters nominal.
Ops 2, issue catalog roll-up command.
And in work. And catalog roll-up command issued. Verifying roll-up digest with engineering is in work.
Ops 2, verify vehicle roll-up digest against the mission SVDD and report when complete.
And that's in work.
NASA PM, verify range TM receiving hard link 87, link 69, and link 41 data.
It's in work.
LC, TLM, countdown 1.
Go ahead, TLM.
Vehicle has been powered, so data stream has been enabled to use NOI, completing step 276.
Copy that, TLM. Check step 276.
LC, NASA PM.
Go ahead, PM.
Step 90, range receiving hard link data on 87, 69, and 41.
Copy, PM.
LC, TLM, step 91, receiving closed loop telemetry.
Copy, TLM and SLM. Verify receipt of Cygnus hardline telemetry.
LC, SLM, we're receiving Cygnus hardline telemetry.
And site control, report status of tail rod and cap pressures.
And rod and cap pressures are nominal, no adjustment required. This was completed earlier as part of the pre-pullback steps.
Copy that, site control. Check steps 93 and 94.
LC Ops 2 and countdown 1.
Go ahead, Ops 2.
Yes, step 89, vehicle roll-up digest verified with engineering.
Copy that, check step 89. GNC 1, provide optimal launch time.
LC, GNC1, optimal launch time for today's operation is year 2022, month 11, day 7, hour 10, minute 30, second 12.165.
Copy that, GNC1, Ops 1, upload optimal launch time to flight computer.
Copy and work. LC Ops 1, optimal launch time uploaded.
LC GNC1, optimal launch time verified in telemetry.
Copy check steps 96, 97. GNC1 provides Cygnus and Antares final mass property inputs.
LC GNC1, stage 2 ignition mass data is unchanged from yesterday's operation.
Copy all. I've got all that information. Do you want to read that out?
Do you want me to read those out?
Yeah, I think since we've not changed that, we'll press on.
Copy.
With just the total stage 2 ignition mass, Cygnus final mass. We don't need to read the memo numbers.
Copy that. The final stage 2 total stage 2 ignition mass is 76823.85 pounds.
SLM verifies Cygnus final mass and reference memo.
LC, this is SLM. I verify no changes from yesterday. Final mass and reference memos are good.
MEC 1, verify Antares final mass and reference memo.
MEC 1, verified. No change from yesterday. Numbers verified.
Ops 1, enter stage 2 ignition mass into flight computer.
LC Ops 1, stage 2 ignition mass entered.
LC GNC1, stage 2 ignition mass verified in telemetry.
And MES2, report fuel density value for operation.
LC MES2, fuel density value 0.8117 grams per cubic centimeter.
Copy check all steps through 103. Ops 1, enter fuel density into flight computer.
LC Ops 1, fuel density value entered.
LC MES1 on countdown 1.
Go ahead, MES1.
Heartbeat density entered 0.812, which is rounded up from 117.
Copy that, MES1. Elect 1, report readiness for stage 2 ECU initialization.
LC, this is Elect 1, ready for stage 2 ECU initialization.
And Ops 1, set, verify ECU command values.
Copy and work. LC Ops 1, ECU command value set.
Ops 1, initialize system.
LC Ops 1, pitch and yaw 0.0 entered, selecting initialize, and starting ECU comm. Message counter is incrementing from the VIC. Step 109.
LC TLM, message counting incremented on the DCOM.
And TLM, report pitch and yaw LVDT positions.
For stage 2 TVC 01, I have 0.101 degrees. Stage 2 TVC 02, I have 0.001 degrees.
LC Elect 1, pitch and yaw LVDT positions are acceptable.
Stage 2 initialization, ECU initialization complete.
LC prop lead, I have FMS ready, step 285.
Copy prop lead. And step 280, place the dynamic limit checker in automatic mode, TLM.
LC, TLM, DLC in automatic mode.
Core 2.
LC, Core 2, DLC in automatic mode.
Chimon.
LC, Chimon, DLC in automatic mode.
And Core 2, verify MS session is running and CSOE is ready for mode 4.1, 4.3 checks.
LC Core 2, MS session running, CSOE ready to support 4.1, 4.3 checks.
Step 282, Prop 2, perform Hartron controller comm checks with OCCS and provide status when complete.
And LC Prop 2, that's in work.
Okay, launch team. While 4.1, 4.3 checks are ongoing, and before we go into our open loop RF and transmitter checks, we need to send the red team in to do a couple of regulator adjustments. Can I get GCE, safety, GSO, and red team lead on anomaly 1?
And LC Prop 2, Hartron controller to OCCS comm checks complete and sat. Step 282 is complete.
Copy Prop 2. And TLM, your go for step 283 at decom stop and restart telemetry archiving.
Copy. In work. LC, TLM, countdown 1.
Go ahead, TLM.
Step 283, archiving restarted, is complete.
Copy that, TLM. And Core 1, your go for step 286.
Core 1 copies, LC. LC, Core 1 on countdown 1.
Go ahead, Core 1.
Yeah, step 286, the MS self-track session is complete.
Copy, Core 1. TLM, disable Usinoya data stream.
LC TLM, data stream suspended.
Check 286 and 287.
And LCGC on countdown 1.
Go ahead, GCE.
Red team work is complete at the pad, and they're departing for Z65.
Copy that. And how would you like to proceed with reopening 5178, 5179, and resetting 5269?
I think we should be, sorry, you want to take this to loading?
Certainly. Okay, launch team, we're just waiting for the red team lead to egress the pad. Once we hear back from them, we'll kick off our open loop RF and transmitter checks, starting with step 114. And GSO, step 288, begin implementation of pad clear zone and report when complete.
LCGSO 1190 set with the exception of Z65, who will remain within this area.
Copy that. And GCE LC on countdown 1.
GC on countdown?
Yeah, step 289. Are we going to stay on secondary for the HPGN2?
Affirmative. Go ahead, LC.
Okay, steps 290, 291, and 292 are not required. GCE, step 293. You could stay on the current leg of the warm helium circuit?
Yeah, this is GC, that's affirmative.
And is that primary on helium?
Yes, that's primary on helium.
And 294, 295, not required. Red team lead, be advised, 293-foot line of sight clear from launch vehicle aft bay required for remainder of operation. Confirm clear.
Copy and confirm clear.
Prop 1, start charging of engine helium bottles.
In work.
Opening VTD on my mark. 2, 1, mark. VTD indicates open. Prop 1, engine bottle charging started.
Copy, Prop 1.
LC admin, VGD state set.
LCMES2, helium bottles charging.
And LC Prop 1, OCCS in auto mode.
Copy all. Check steps through 300. And step 114, poll for open loop RF and transmitter checks. Safety.
Safety is go.
GSO.
GSO go.
NASA TD.
NASA TD's go.
SLM.
SLM go.
Ops 1.
Ops 1 go.
Elect 1.
And elect 1 is go.
Ops 1, verify RF switches at lower.
LC Ops 1, C-band RF switch set to lower in green. TLM RF switch set to lower in green.
NASA PM, verify range is not interrogating vehicle transponder.
LC NASA PM, range confirms not interrogating vehicle transponder.
And Ops 1, apply external power to transponder RF switch.
Transponder RF switch, external power on. The time is 07:34:13. LC Ops 1, transponder RF switch, external power nominal.
And RF switches are set to lower.
Copy Ops 1 on Ops 2, check steps 118 and 119, waiting 2 minutes. And NASA PM, confirm active radar sites and begin C-band transponder interrogation per the Antares mission radar transponder interrogation checklist.
Yes, sir, in work.
LC safety stepping off comm.
Copy safety.
LC NASA PM, radars are active.
Copy PM, and that's radars 3, 5, and 18, correct?
We're starting one radar at a time.
Yep, understood. Just making sure I've got the right 3.
Is correct. 3, 5, and 18.
And Ops 1, apply external power to vehicle transmitters. Step 123.
LC Ops 1, avionics telemetry transmitter, external power on. Motor cone transmitter external power on. Stage 1 telemetry transmitter external power on.
External power status nominal.
LC Ops 1 vehicle transmitters external power nominal.
And NASA PM Step 126, confirm range is receiving open loop telemetry from all vehicle links.
That's in work. LC, Step 126, range receiving open loop 41, 69, and 87.
Copy that. PM and PM direct range TM to switch to recording open loop telemetry.
In work. LC NASA PM Step 127, range recording open loop telemetry.
Copy that. PM and NASA PM begin S-band assessment.
Roger, that's in work.
And TLM, configure DCOM source to open loop telemetry.
LC, TLM, copy and work. LC, TLM, decom switch to open loop telemetry.
And step 130, verify open loop telemetry received and nominal. TLM.
LC, TLM, telemetry, open loop telemetry received and nominal in the MCC.
MES2.
LCMES2, open loop telemetry received and nominal in the cab.
SLM.
LT, SLM, open loop telemetry received and nominal in H100.
And NASA PM, step 131, status, the S-band assessment. Confirm assessment email to launch vehicle recipients.
LC, we'll get that to you as soon as it gets done. It'll probably 10 or 15 minutes yet before we can get that to you.
Okay, PM, thank you.
LCTD, we're green for toxins and debris.
LC copies.
LCMES2, step 303, warm helium system, steady state observed.
LC copies.
LC NASA PM.
Go ahead, PM.
Yes, sir. Are you ready to switch over to LAA? We did have, on Leak 87, we had multiple dropouts.
Okay, PM, yeah, I think we're ready to switch over.
All right, stand by. LC NASA PM.
Go ahead, PM.
Yes, sir. The LAA is forced now as a limited resource.
Copy that. Assessment underway.
LC prop lead. I have step 301 for you, start of heated GNT supply.
Copy that, prop lead. And prop 1, your go for step 302. Adjust EREG 5269 to 1350 PSIG.
In work. And LC Prop 1, 5269, adjusted to 1350 PSIG.
LC copies.
LC NASA PM.
Go ahead, PM.
Yes, sir. We can give you step 121. All radars are holding beacons.
Copy that, NASA PM. Check steps 120, 121. And NASA PM step 122, proceed with C-band evaluation and report when complete.
Sir, that should be out any second now. We're looking for it to come through email. LC NASA PM.
Go ahead, PM.
Sir, we can give you 128 also. We began S-band assessment, so that'll be, we're still waiting for that as well.
Okay. Check step 128, standing by for 131. And NASA PMLC on countdown 1.
NASA PM, go.
Yeah, we're ready to switch off of LAA back to best source.
Roger. Stand by. LC NASA PM.
Go ahead, PM.
Yes, sir. We're back where we're best source selector on telemetry.
Copy that, PM. Thank you.
Go, RSM. LC NASA PM.
Is there a call for LC?
Yes, sir. NASA PM. LC, I can give you step 122. You have a C-band evaluation. It should be in everybody's email box.
Copy that, PM. I see that now. Check step 122.
LC NASA PM.
Go ahead, PM.
Yes, sir. I can give you 131. We have S-band assessment complete. Should be in everybody's email box.
Copy that, NASA PM. Standing by for receipt. Elect 1, LC on countdown 1.
Elect 1.
Step 132, confirm receipt of S-band assessment and report status.
Copy that. Assessment has been received. Evaluation and work. LC, this is LEC 1. S-band assessments, nominal.
Copy LEC 1. And TLM, switch decom source to closed loop telemetry.
LC, TLM, copy and work. LC, TLM, decom switch to closed loop telemetry.
Copy TLM. Step 134, verify closed loop telemetry received and nominal. TLM.
TLM, closed loop telemetry received and nominal in the MCC.
MES2.
LC MES2, closed loop telemetry received and nominal in the cab.
SLM.
LC, SLM, closed loop telemetry received and nominal in H100.
And NASA PM, step 135, direct range TM to switch to recording orbital decom source.
Roger, inward. LC NASA PM 135, range recording orbital decom source.
Copy. NASA PM, check step 135. At this time, I'd like to poll for FTS external power on, step 136. Safety?
Safety is go.
GSO?
GSO go.
FSO?
FSO go.
NASA TD?
TD's go.
Ops 1?
Ops 1 go.
Ops 2?
Ops 2 is go.
Elect 2?
Elect 2 is go.
Go for external power on. FSO, bring up command transmitter with check channel on.
In work. LC, Wallops CT site on. Check channel radiating.
Copy FSO. Ops 1, apply external power to FTSA and FTSB.
LC Ops 1, FTSA, external power on. FTSB, external power on.
FTS external power nominal. FTS safe, receiving check channel, signal strength nominal.
Copy Elect 2. NASA PM, verify range radar and range telemetry ready to monitor C-band and S-band operation during avionics internal power test.
Yes, sir. Range is ready to support.
Step 142, poll for avionics and FTS internal power test. GSO.
GSO go.
FSO.
FSO go.
NASA TD.
TD's go.
Ops 1.
Ops 1 go.
Elect 1.
Elect 1 is go.
Ops 2, start battery logging.
And battery logging on. Lithium-ion battery monitor comm is nominal.
Check steps 143, 144. Ops 1, transfer avionics and FTS power to internal.
LC Ops 1, all internal power on. The time is 08:05:08. LC Ops 1, all external power off.
LC Elect 1, internal power is nominal.
And NASA PM, verify with range radar, no change in C-band operation.
Inward, standby. LC NASA PM.
Go ahead, PM.
Sir, step 148. C-band operation confirmed nominal. Step 149, S-band operation confirmed nominal.
Copy, PM. Check steps through 149. Ops 1, switch avionics and FTS external power on.
LC Ops 1 and work. LC Ops 1, all external power on. LC Ops 1, all internal power off, and the time is 08:07:10.
Select 1, LC on countdown 1. Step 152, report avionics and FTS external power status.
LC Elect 1, avionics external power nominal.
Ops 2, remove lithium-ion battery monitor power and discontinue logging.
And in work. And lithium-ion battery monitor power is off, and logging is off.
Check step 153. Red team lead, be advised 400-foot launch pad clear required during FTS internal power and arm command test. Confirm clear.
Red team lead copies and confirms clear.
Step 155, poll for FTS arm command test, FSO.
FSO go.
NASA TD.
TD's go.
Ops 1.
Ops 1 go.
Elect 2.
Elect 2 is go.
Ops 1, transfer FTSA and FTSB to internal power.
LC Ops 1 and work. LC Ops 1, FTSA and B, internal power on, external power off, and the time is 08:09:04. And FTS status nominal.
FTS internal power nominal, ready for FTS receiver arm.
FSO, send FTS receiver arm command for 2 seconds and continue check channel when function removed.
FSO, arm on my mark. 3, 2, 1, mark. +1, +2, arm removed. Check channel continued.
FTS arm indication received. FTS currently indicates safe.
FSO, verify FTS arm indication.
FTS arm indication.
FTS safe in arm and FTLU safe.
Check steps through 162. Ops 1, open FTS UMBI loop and verify green indication.
LC Ops 1, FTS UMBI loop open and green.
FTLU and FTS receiver indications are nominal.
And Ops 1, close FTS UMBI loop and verify red indication.
LC Ops 1, FTS UMBI loop closed and red.
Ops 1, transfer FTSA and FTSB to external power.
In work. LC Ops 1, FTS A and B external power on, internal power off, and the time is 08:10:53.
FTS external power status, voltage, and current nominal.
Copy all. Check steps through 167.
FTS safe, configuration verified, check channel being received. FTLU AGC is 4.85. FTLU-B AGC is 4.77.
Copy all elect 2. Check step 168.
Hey, LC, this is prop lead. I have step 304 for you.
I was just going to call you prop lead. Go ahead.
Yeah, phase 3 flow rate is nominal and does not need adjustment, so 305 is not required.
Copy that. Check steps 304 and 305. And Core 1, near go for step 306. Direct Ujinoya to begin second MS session at T-minus 1 hour, 40 minutes.
Copy LC in work.
And site control, step 307, verify ECS air 2 points.
And Core ACU1 is reading negative 31.8, and Core ACU2 is reading negative 29.7.
Copy that, site control. And steps 308, 309, 310, 311 are complete.
And LC 311 was not required today.
LC copies. All right, team, at this time I'd like to proceed with our Safe and Arm and ODM enable tests. Step 169, red team lead, be advised, 400-foot launch pad clear required during SA arm and ODM enable test. Confirm clear.
Copy and confirm clear.
Ops 2, initialize ground EPV power supplies.
And ground EPV power supplies initialized.
Ops 2, initialize ground ordnance power supplies.
And ground ordnance power supplies initialized as well.
Ops 1, transfer FTSA and FTSB to internal power.
LC Ops 1 in work. LC Ops 1, FTSA and B internal power on, external power off, and the time is 08:15:38.
Copy, Ops 1. FTS internal power parameters nominal. Copy, Elect 2, Ops 1, activate arm enable.
LC Ops 1, arm enable rotated, arm enable illuminated.
And Ops 1, send all arm command.
LC Ops 1, all arm command sent.
Check steps through 175.
LC Elect 1, ground ODM armed, stage 1 controller ODM armed, flight computer ODM armed, stage 2 ignition and Aura SNA's arm indication, FTS SNA arm indication.
Copy all, Elect 1, check step 176. Ops 1, safe vehicle SNAs and vehicle and ground ODM and verify ODM safe.
LC Ops 1 in work. LC Ops 1, vehicle SNAs and vehicle and ground ODM safe.
LC Elect 1, ground ODM safe indication, stage 1 controller ODM safe indication, flight computer ODM safe indication, stage 2 ignition and Aura SNA safe indication, FTSA and FTSB SNA safe indication.
Copy all, Elect 1, check steps 177, 178. Ops 2, reset ground ODM power supply.
And ground ODM power supplies reset.
Ops 1, transfer FTSA and FTSB to external power.
LC Ops 1, FTSA and B, external power on, internal power off, and the time is 08:17:44.
FTS external power status, voltage, and current nominal. Copy, Elect 2. Ops 1, remove FTS power.
LC Ops 1, FTSA and B, power off.
And FSO, secure CT site and verify RF silence.
In work. LC, CT site key down, RF silence verified.
Copy that, FSO. Ops 1, deactivate arm enable at failsafe panel.
LC Ops 1, arm enable key rotated, arm enable no longer illuminated.
NASA PM, cease C-band transponder interrogation and deactivate radar sites.
Yes, sir. 185 C-band transponder interrogation stopped. Radar sites deactivated.
Copy that, PM. Check all steps through 185. Step 312, verify readiness to perform engine pressure switch check. MES2.
MES2 is go.
Ops 1.
Ops 1 go.
Elec 1.
Elec 1 is go.
Ops 1, activate engine pressure switch check.
Pressure switch check on my mark. 3, 2, 1, mark. Pressure switch check activated.
And Elec 1, your go for step 314. Verify engine pressure switch check nominal.
Pressure switch check is nominal.
And TLM, your go for 315 and 316.
Copy and work.
LC Core 1 on countdown.
Go ahead, Core 1.
I have step 306 for you. The second MS session has started with a start time of 081743 UTC.
Hey, Core 1, can you repeat that time? I have 08 and then I lost you.
It's 081743 UTC.
Copy that, Core 1. Check step 306.
LC TLM. I have 315 and 316 Ujnoid data stream started and GTLM split and logging started.
Copy that, TLM. Check steps 315 and 316. Core 1, request Ujnoid to verify orbital decom data is being received and recorded, and MTU hardline data is being received and recorded. Report when complete.
Copy LC and work.
And TLM LC on countdown 1 is 318 dependent on 317, or can you verify that now?
I was waiting on it, but I can verify that we are receiving stage 1 telemetry from Ujnoid.
Copy that, TLM. At step 319, confirm nominal Ujnoid vehicle telemetry. TLM.
Confirm nominal display of Ujnoid telemetry in the MCC room 117.
And Elec 1.
LC Elec 2 is going to go for Elec 1 on this one. Nominal display of Ujnoid telemetry is confirmed.
Thanks, Elec 2. And Core 2. And Core 2, LC on countdown 1.
LC, this is Core 2, nominal display of GTLM in E100.
Copy that, Core 2. Check steps 318 and 319. And launch team, we are coming up about 13 minutes from our 30-minute hold. Holding at CDT, T-minus 1 hour 20 minutes. UTC of 8:37:43. We are standing by for step 317. However, at this time, we will proceed with our EHS functional test, step 186. Poll to perform stage 1 EHS functional test. GSO.
GSO go.
Prop 2.
Prop 2 is go.
Prop lead.
Prop lead is go.
Ops 1.
Ops 1 go.
Ops 2.
Ops 2 is go.
EHS 1.
EHS 1 go.
EHS 2.
EHS 2 is go.
MES 2.
MES 2 is go.
ACE.
ACE go.
Ops 2 initialize ground EPV power supplies.
In work. And ground EPV power supplies initialized.
And elect 1, LCN countdown 1, step 188, verifying telemetry ground EPV power supplies are initialized.
LC elect 1, ground EPV power supplies initialized, voltage is nominal.
Check step 188. Ops 1, activate arm enable.
LC Ops 1, arm enable rotated, arm enable illuminated.
Ops 1, arm ground ODM.
LC Ops 1, ground ODM armed.
LC elect 1, ground ODMs 4 through 7 indicate armed.
LC Ops 1, ground APV ODMs indicate armed. Ground ordnance ODMs remain safe.
Check step 191, 192. Ops 1, deactivate arm enable.
LC Ops 1, arm enable key rotated, arm enable no longer illuminated.
Ops 2, set ground EPV VREFs.
And ground EPV VREFs are set.
LC elect 1, ground EPV refs nominal.
Check step 194, 195. Red team lead, be advised 51-foot vehicle clear required until completion of hydraulic supply to EHS. Confirm clear.
Copy and confirm clear.
And I got confirmation step 317 is completed on BACnet. Step 197, prop lead, verify accumulators 8006 and 8007 are ready for EHS functional.
LC prop lead, accumulators verified ready.
Prop 2, place OCCS into SAC mode, pause HSS ASC.
LC Prop 2, that's in work. LC Prop 2, HSS ASC is paused.
Prop 2, open valve 8021.
LC Prop 2, that's in work. (8021) open on my mark. 3, 2, 1, mark. (8021) is open.
LC prop lead, hydraulic supply valve configuration verified.
Prop 2, configure HSS GN2 pressure to accumulators.
LC Prop 2, that's in work. LC Prop 2, 5464 closed, 5463 is open.
And HSS GN2 valve configuration verified.
LC, EHS1, pressures verified nominal.
Check steps through 203. Ops 1, transfer SMI A and B power to internal.
Copy and work. LC Ops 1, SMI power to internal. LC Ops 1, TVC and EHA buses enabled.
Elect 1, step
LC Elect 1, SMI power nominal.
Copy that, Elect 1. Ops 1, initialize stepper motors to their null positions.
Initialize all, initialize on my mark. 3, 2, 1, mark. And the time is 08:30:45.
LC, EHS-1, stepper motors are at the null position.
Ops 1, set radial and conical ramp rates for EHS functional.
Copy and work. LC Ops 1, ramp rate set. LC Ops 1, stop limit at 4.2, and engine positioning is in synchronized.
Copy Ops 1, engine position mode set to synchronized. Check steps 210 through 211. Ops 1, start TVC actuator comm.
LC Ops 1, actuator comm started.
Ops 1, start TVC sweep test. Ops 1 to announce start of each cycle, EHS 1 to confirm after each cycle.
Starting the 4-degree radial conical slew test on my mark. 3, 2, 1, mark.
Sweep complete, ready for next cycle.
Starting the next 4-degree radius conical slew test on my mark. 3, 2, 1, mark.
Sweep complete, ready for next cycle.
Starting the third 4-degree radius conical slew test on my mark. 3, 2, 1, mark.
TVC sweep complete and set.
Copy EHS 1, check steps 213, 214. Ops 1, stop TVC actuator comm.
LC Ops 1, EHA TVC actuator comm stopped.
Ops 1, start EHA actuator comm.
LC Ops 1, EHA actuator comm started.
Check step 216. Ops 1, start EHA sweep test.
Starting EHA 50 Hertz sweep test on my mark. 3, 2, 1, mark. Test in progress.
EHA sweep complete and set.
219, Ops 1, stop actuator comm.
LC Ops 1, EHA actuator comm stopped. LC Ops 1, TVC and EHA buses disabled.
Ops 1, close EHS hydraulic supply valve.
Closing 8020 on my mark. 3, 2, 1, mark. 8020 reports closed.
8020 verified closed.
Check all steps through 222. Ops 1, transfer SMI-A and B power to external.
Copy and work. LC Ops 1, SMI power to external.
LC, HS1, hydraulic pressure has been removed from the vehicle.
And Prop 2, reconfigure HSS GN2 valves to pre-launch configuration.
LC, Prop 2, that's in work. LC, Prop 2, HSS, GN2 valves reconfigured, HSS, GN2 is venting.
LC prop lead, HSS GN2 vented.
LC, Prop 2, closing, 8021. 8021 is closed, and continuing on step 228, resuming resuming the HSS auto sequence and returning OCCS to auto mode.
Copy that, Prop 2. Check all steps through 228. This completes our EHS functional test, and I can confirm CDT is holding. And Red Team leads, step 321. Evacuate Red Team to V50. Notify upon arrival.
Copy that, en route to V50.
And Launch Team, be advised, since we got to our EHS functional test a bit later than nominal, we'll need to re-perform our engine pressure switch checks. Steps 312, 313, and 314. Starting on 312, verify readiness to perform engine pressure switch check, MES2.
MES2 is go.
Ops 1.
Ops 1 go.
Elect 1.
Elect 1 is go.
And Ops 1, activate engine pressure switch check.
Pressure switch check on my mark. 3, 2, 1, mark.
LC, elect 1, pressure switch check is nominal. Health check error has cleared.
Copy that. Ops 1, did I hear you say pressure switch check activated?
Yes, pressure switch check activated.
Okay. Check steps 312 through 314. MES2 LC on countdown 1.
Go ahead, MES2.
I'm ready for step 322.
Yeah, fuel inlet valve is closed. Engines are not primed. Steps 405, 406 not required. Steps 412, 413 required. Step 422, 430 required.
Copy all MES2, check step 322. And side control, re-verify ECS air dew points.
And dew point for ECU1 is negative 32.4, and dew point for core ECU2 is negative 26.9.
Copy side control, GCE, verify heated GN2 pressure and temperature.
This is GC, heated GN2 pressures and temperatures are nominal.
Check step 324. At this time, I'd like to proceed with our discrete tests. Step 229, report readiness for calibration of engine pressure sensors, MES2.
MES2 is go.
EHS1.
EHS1 is go.
ELEC1.
ELEC1 is go.
And OPS1, set engine pressure sensors to cal mode.
LC Ops 1, engine pressure sensor to cal, wait 5. Engine pressure sensor to flight. Engine pressure sensors recalibrated and returned to flight.
LC ELEC1, engine pressures calibrated, executed, and verified in flight mode.
And OPS1, set charge amps to flight mode.
LC Ops 1, charge amps set to flight mode.
LC ELEC1, engine sensor charge amps verified in flight mode.
Check steps through 233. And ELEC1, step 234, report status of discrete signals.
LC ELEC1, discrete signals verified nominal.
Press local launch enable button at failsafe panel and verify indicator is illuminated. Step 235, OPS1.
LC Ops 1, launch enable enabled.
GSO.
LC GSO, launch enable verified.
Step 236, verify local launch enable indicator at failsafe panel is illuminated. RSO.
RSO, launch enable verified.
FSO.
FSO, launch enable verified.
NASA PM.
NASA PM, launch enable verified.
NASA TD.
TD, launch enable verified.
Check step 236. OPS1, verify global launch enable indicator at failsafe panel is illuminated.
LC Ops 1, global launch enable verified.
LC ELEC1, discretes verified nominal.
Step 239, cycle local launch enable button. RSO.
In work. LC, RSO, launch enable cycled, indications nominal.
FSO.
Hold on my mark. 3, 2, 1, mark. +1, +2, +3, release. Launch enable cycle, indications nominal.
NASA PM.
NASA PM, hold on my mark. Mark. Release. LC launch enable cycled, indications nominal.
NASA TD.
Inward. Program will hold on my mark. 3, 2, 1. Hold. And release. LCTE launch enable cycle, indications nominal.
Ops 1.
LC Ops 1, launch enable cycled, indications nominal.
And GSO.
LC GSO, launch enable cycled, indications nominal.
Copy. Check step 239. GSO, remove local launch enable.
LC GSO, launch enable removed, verified off.
LC Ops 1, launch enable removed, verified off, and global launch enable, verified off.
Copy that. Check steps 241 and 242. This completes our discrete tests. And LWO, LC on countdown 1. We're go for step 325. Provide updated weather briefing on countdown 1.
LC, this is Elwo on countdown 1 with tonight's updated weather briefing. We are looking at good conditions across the area. Continuing, we just have a few clouds out there right now at 7,000 feet with unrestricted visibilities. Our winds are currently out of the south-southwest at 5 to 10 knots with a temperature at 65 degrees and our relative humidity right around 90%. The satellite imagery looking pretty favorable for us right now. We are seeing the clouds that were approaching from the west continuing to fall apart and decay, and that's going to provide us with mostly clear to partly cloudy skies as we go through the remainder of the countdown and into the launch window. Taking a look here at our modeling and what we are seeing from the latest updates, kind of verifying what we're seeing on the current satellite with very little in the way of coverage predicted as we go through the next couple of hours. So not anticipating any kind of cloud ceiling concerns at this time. We'll continue to monitor to make sure we don't see any quick development of any patchy fog out there, but right now not any indication that that's in the cards for us for the next couple of hours. So countdown forecast showing just a couple of layers of scattered stratus clouds around 6,000 to 7,000 feet, winds out of south-southwest at 7 to 12 knots, temperature in the mid-60s, and that relative humidity around 90%. Launch forecast showing pretty much the same conditions in our launch window with a scattered deck at 6,000 and another deck at 7,000. So not really seeing any issues out there. Currently we are green for weather and we are anticipating green conditions for our launch window. That concludes our weather briefing. Any questions?
Thank you, Elwo.
My pleasure.
And launch team, at this time, we're in our 30-minute hold. With 19 minutes remaining, we will resume our countdown at 9:07:43 Zulu. Currently waiting for the red team to get to Victor 50. LC stepping off station.
LC, red team lead, countdown 1.
Call for LC.
Yeah, LC, red team lead. The red team has arrived at V50.
Copy that, red team lead. Glad you're safe. GSO, step 326. Confirm pad clear zone implemented.
GSO, pad clear zone established.
Check step 326. This completes all steps on our checklist through 327. Okay, launch team, we're coming up on our poll for readiness to begin propellant loading operations. The engine team is investigating some parameters on the fuel inlet valve, but it seems as though their discussions with Energomosh and ACE that they're comfortable proceeding. We'll be coming up on our poll here in just about 40 seconds. All other systems are reporting green. And to clarify, the open questions on the KKG switches, that is not a red condition at this time. And step 328, poll for readiness to begin propellant loading operations. Mars site.
Mars site is go.
GSO.
GSO go.
RSO.
RSO go.
NASA TD.
TD's go.
CMD.
CMD go.
Safety.
Safety is go.
Prop lead.
Lead go.
Stage 1.
Say when to go.
GCE.
GC's go.
ACE.
ACE is go.
LD.
LD is go.
Go to begin propellant loading operations at T-minus 1 hour, 20 minutes. Steps 331 and 332 are not required. And step 333 is complete. And step 334 is complete.
LC, TLM, countdown 1.
Go ahead, TLM.
Step 330 is complete. Archiving restarted.
Copy, TLM. Check step 330. And launch team, I can confirm countdown has resumed. Start of core low flow RP loading and low flow LO2 chill down to occur at T-minus 1 hour, 16 minutes. Phase 2 dynamic limits will be active.
LC prop lead, we have start of core low flow RP loading and low flow L2 showdown.
Copy that, lead. Check step 336.
And we are right above our flight rule for our flow rates for low flow and L2 showdowns. So I think we are good, and those steps are not required.
Copy, lead. Step 338, not required.
And LC prop lead step 339, I have confirmed start of core high flow RP loading.
Copy that, prop lead. Check step 339.
And LC prop lead at start of core high flow at L2 showdown, step 340.
Copy that, lead. At this time, I'd like to report readiness for accumulator refill per Appendix Michael, step 341, GCE.
GCEs go.
EHS.
EHSs go.
Ops 1.
Ops 1 go.
Prop 2.
Prop 2 is go.
Prop lead.
Prop 3 is go.
Go for refill. Prop 3, your go to execute Appendix Michael. Report when complete.
Anomaly 2?
Yes, please, Anomaly 2.
Copy that.
And launch team current status. Team is currently refilling the HSS accumulators and will be coming up on LO2 low flow loading. T-minus 56 minutes. The engine team is looking into some unexpected voltage values on KKG, and we're exploring steps required to begin evacuation of the engines early and priming early. This would put us at risk if we do have to scrub, would push out our next launch attempt a bit longer than desirable. But this is the recommendation currently from the main engine team as well as Energomash. The steps are being put together, and we'll report back when we have a complete picture.
Copy, Adam.
LC, this is Prop 3. HSS accumulator refill is complete.
Copy that, Prop 3. Check step 342.
LC prop lead, step 343, low flow L2 loading has started.
Copy that, lead.
LC prop lead, step 344, high flow L2 loading has started.
Copy that, lead. Check steps through 344. GNC1, LC on countdown 1. Step 345, provide flight computer trajectory file for launch operation.
LC GNC1, we would like to select trajectory file 1 for today's operation.
Copy. GNC1, Ops1, upload flight computer trajectory file.
LC Ops 1, trajectory file 1 selected.
LC GNC1, trajectory file 1, verified in telemetry.
LC Ops 1, ground to vehicle comm nominal.
Ops 1, verify orb nav settings.
Copy and work. LC Ops 1, orb nav settings verified.
And Ops 1, initialize nav position.
LC Ops 1, orb nav position sent.
LC GNC1, orb nav telemetry verified.
Copy. GNC1, check step 351. Step 352, report readiness for GC align. GNC1.
GNC1 is go.
Ops 1.
Ops 1 go.
Elect 1.
Select 1 is go.
Ops 1, mode orb nav to GC align.
Orb nav and GC align, and the time is 09:36:12.
Check 353. And GNC1, LC on countdown 1. Step 354, verify OrbNav telemetry.
Stand by, LC. Need more time.
NASA PM, step 359, reactivate radar sites and reinitiate C-band transponder interrogation.
Roger, LC. That's in work.
LC, GNC1, step 354, OrbNav telemetry verified.
Copy that, GNC1.
LC, NASA PM.
Go ahead, PM.
Sir, 359, we have radars active.
Copy that, PM. And 360, verify range holding beacon on all radar sites.
Stand by on that. I'll get back.
And launch team, be advised, steps 357 and 358 will be delayed until loss of hardline data.
LC, NASA PM.
Go ahead, PM.
Yes, sir. We've got radar 5, radar 3 locked. It'll take a few more minutes for 18, but you have a good transponder.
Copy that, PM. Check step 360.
LC prop lead, I have cold helium ballast submerged.
Copy that, lead. Check step 355. LC stepping off station.
LC prop lead, we have cold helium bottle charging started.
Copy that, lead. Check step 356. Step 361, Ops 1, enable local launch enable button at failsafe panel and verify local indicator is illuminated.
LC Ops 1, launch enabled and illuminated.
GSO, enable local launch enable button at failsafe panel and verify local indicator is illuminated.
LC GSO, launch enabled and illuminated.
Step 363, verify RCC enable abort buttons are enabled and illuminated. NASA PM.
LC NASA PM enabled.
RSO.
RSO enabled.
FSO.
FSO enabled.
NASA TD.
TD enabled.
Check step 363.
LC Ops 1, global launch enable verified.
LC Elect 1, launch enable verified.
Check steps 365. Ops 1, stop sending ECU commands.
LC Ops 1, ECU commands halted.
And step 367, pull for final FTS power on and arm command test. Safety. Safety is go. FSO.
FSO go.
Ops 1.
Ops 1 go.
Elect 2.
Elect 2 is go.
FSO, bring up command transmitter with check channel on.
In work. LC, Wallops CT site on, check channel radiating.
Copy FSO. Ops 1, apply external power to FTSA and FTSB.
FTSA, external power on. FTSB, external power on.
FTS external power nominal.
FTS safe configuration verified. Check channel being received. AGC levels nominal.
Copy that, Elect 2. Ops 1, transfer FTSA and FTSB to internal power.
Copy and work. LC Ops 1, FTSA and B internal power on, external power off, and the time was 09:51:44.
FTS internal power nominal.
FSO, send FTS arm command for 2 seconds, then remove. Continue check channel when function removed.
FSO, arm on my mark. 3, 2, 1, mark. +1, +2. Arm removed. Check channel continued.
FTS arm indication received. FTS currently indicates safe.
FSO, verify FTS arm indication.
FTS arm indication.
FTS safe and arm and FTLU safe.
Check all steps through 377. And step 378, report readiness for recalibration of engine pressure sensors. MES2.
MES2 is go.
EHS1.
EHS1 is go.
Ops1, recalibrate engine pressure sensors.
Copy and work.
Well, good morning, everyone, and welcome here to the launch pad, or maybe it's good afternoon or evening, depending where in the world you're joining us from. Welcome to our live launch coverage of NASA Northrop Grumman Cygnus CRS-2 NG-18 SS Sally Ride Antares 230 Plus launching out of Wallops, Virginia in the United States. It's great to have you all here joining us for the last launch of the Antares 230 Plus rocket. The last one using Ukrainian and Russian components ahead of an upgraded Antares 330 fully American built rocket that'll be coming out in the next couple of years. But on board is the Cygnus spacecraft with over 8,200 pounds of cargo and resupplies for the International Space Station, and we are coming up to just 30 minutes 40 seconds and counting until launch. If you've been joining us for a while, we've been listening into one of the most active public mission control nets we ever hear. So we really appreciate NASA just having that feed and being able to listen in over the last over 4 hours as they've prepared for launch here today. This is the 17th launch of any Antares vehicle of any variant, the 12th of the 230 version. It's going to be the 19th Cygnus spacecraft ever to launch and the 7th on a 230 plus variant, and we're at the 154th orbital launch attempt of 2022 of any space agency. If it's your first time here, though, welcome here at the launch pad. It's our mission to inform and inspire the explorers of tomorrow, because we believe that space is better together. And if you haven't yet, take a moment, engage that subscribe button so you never miss another live launch coverage, space briefing, space news update, or exclusive one-on-one interview. We're glad to have you joining us here today. And if you haven't yet, take a moment, engage that like button. Let's see if we can get to that 500 mark before launched here early this morning. If you were waiting to join us yesterday, this was going to have a launch attempt yesterday. They got through a large portion of the count, but they did need to scrub yesterday due to some stuff with the rocket and then a fire alarm at mission control, which turned out to be a false alarm. So we're back here 24 hours later for a recycle, getting ready to see Cygnus begin its journey up to the International Space Station. We, of course, will be live for the rendezvous and capture of the Cygnus spacecraft. That is currently scheduled to occur at 5:05 a.m. Eastern Time on Wednesday, November 9th. We're going to be getting our live coverage right around 3 a.m. Eastern Time as we watch for that final rendezvous and capture. Installation of the Cygnus cargo craft is scheduled right around 7:15 a.m. Eastern Time. So we'll be staying live throughout that period there, watching the location of the ISS as they get ready to berth the Cygnus spacecraft there with over 8,200 pounds of fresh cargo and food and water and a whole bunch of resupplies. NASA's getting ready to spool up their live feed in just over a minute here. So once they go live, we will patch them in and listen in to mission control as we have been doing throughout this evening. But we'll also listen in to NASA's official commentary as we count down that final 28 minutes or so here until launch. If you guys have questions throughout today's launch, you can send those in the chat by tagging us at the launch pad, and we'll be working on answering those live to the best of our ability. We're going to get everything spooled up, listen in to NASA, so stay with us right here on the launch pad as we count down to launch of the final Antares 230 Plus rocket. Stay with us.
This is Mission Control Houston. It's launch day, and on your screen is a live look at the Mid-Atlantic Regional Spaceport on Wallops Island in Virginia. Northrop Grumman's Antares rocket is getting ready for liftoff from Launch Pad 0A to kick off a cargo resupply mission carried out by Northrop Grumman's Cygnus spacecraft. Launch is expected in less than 30 minutes from now at 4:27 and 42 seconds a.m. Central, 5:27 and 42 seconds a.m. Eastern with a 5-minute launch window. So far, everything's on track for an on-time launch. This is the second launch attempt for this uncrewed mission. Yesterday, during the final minutes of the countdown, a fire alarm sounded at the Northrop Grumman Cygnus Control Center in Dulles, Virginia, causing the team to have to evacuate the building. The team was responsible for monitoring Cygnus during launch and ultimately taking control of the spacecraft once the spacecraft separated from the solid rocket motor second stage about 9 minutes after liftoff. Yesterday, the team was not tracking any issues with the Cygnus spacecraft, the Antares rocket, ground communication systems, weather, anything like that. Speaking of weather, for this launch attempt, the weather is forecast to be 80% favorable, so there's a very low probability of violation due to weather. Temperatures at NASA's Wallops Flight Facility are in the mid-60s, and weather officers don't expect weather to be any kind of constraint on today's launch. While today's Antares launch will put on a light show for some of the eastern seaboard, should be visible in the states surrounding the Mid-Atlantic region, the Cygnus vehicle up top is the spacecraft making its way to the International Space Station today. You can see it just inside the fairing there on the other side of that American flag towards the top of the rocket. It's carrying 8,200 pounds of scientific experiments, food, hardware, and supplies to the people living aboard the International Space Station, and the Antares rocket is below. And we'll get into some of the launch milestones Antares will go through in just a minute. The mission we're talking about today is Northrop Grumman's 18th Commercial Resupply Services mission for NASA, and after today's launch, Cygnus will travel on a 2-day journey to the International Space Station. It'll be robotically captured at approximately 4:05 a.m. Central Time, 5:05 a.m. Eastern Time on Wednesday, November 9th at the hands of NASA astronaut Nicole Mann, backed up by NASA astronaut Josh Cassada, both inside the robotic workstation in the 7-window cupola.
And Ops 1, Step 393, activate arm enable.
Mann will use the Canadarm robotic arm to grapple Cygnus, and then turn over operations to robotic specialists here in Mission Control, who will bolt it into place on the Earth-facing port of the station's Unity module.
AM's armed.
Ops 2, set Stage 1 controller EPV VRES.
And it worked.
Cygnus began its journey in Dulles, Virginia. From there, it traveled to NASA's Wallops Flight Facility to be mated with the service module that holds the spacecraft's solar arrays. It then traveled to nearby Wallops Island for fuel and integration with the Antares rocket in the Horizontal Integration Facility, also known as the HIF. The rocket and spacecraft traveled horizontally to Launch Pad 0A on Wednesday, November 2nd. Some beautiful shots of it on its way to the launch pad there.
LC stage 1 on countdown it.
Can you provide status of cold helium bottle supply pressure?
Stand by, we're still evaluating.
While the bulk of the cargo was loaded ahead of time, some more time-sensitive late-load cargo was brought in at the launch pad. At pad 0A, Antares is raised vertically, a process that takes about 30 minutes or less for a combined system test. It was put back into the horizontal position Thursday night to allow for the late-load cargo. A pop top on the nose cone creates an opening, and a mobile payload processing facility is used to put cargo in 24 hours before launch. That's the box in the biggest photo towards the left. This could include scientific experiments or even fresh fruits and veggies from the local community stowed for the astronauts.
LC stage 1 on countdown.
Go ahead, stage 1.
Helium topping is not required.
Copy that, stage 1. Check step 391, 392, not required.
Northrop Grumman has a history of naming its Cygnus spacecraft after a pioneer of human spaceflight. The Cygnus spacecraft launching today is named the SS Sally Ride. Dr. Ride was a NASA astronaut and physicist. She was the first American woman to fly to space, kicking off her spacefaring career during the STS-7 mission. She was also a crew member of STS-41G in 1984. Both spacecrafts occurred on Space Shuttle Challenger. An advocate for student outreach, she co-led the creation of the Earth Cam, where students can control a camera outside of the International Space Station to take photographs of the Earth. The program is still operational today. There's no doubt her pursuit of exploration made a mark on human history, with her legacy still ongoing today. We're now just 20 minutes away from launch. The majority of the cargo launching aboard the SS Sally Ride is supplies for the people living in orbit, but Cygnus is also carrying nearly 2,000 pounds of scientific experiments. These will directly support dozens of the more than 250 science and research investigations that will occur during Expedition 68. Shortly after launch, we'll get some more details on how this mission will support upcoming spacewalks outside of the space station for future IROSA solar array deployment from NASA's Jeff Arend. Until then, let's take a look at some of the science experiments on board Cygnus, launching to the International Space Station today.
Yeah, I'd like to...
And if you're just joining us, welcome here to the launch pad. On the right side of your screen, there is a live view of Launch Area 0A at the Wallops Flight Center in Virginia in the United States. As we now count down, we just synced our clocks there with NASA, 18 minutes, 25 seconds, and counting until liftoff of the final Antares 230 plus rocket, the 17th Antares rocket to launch in any variant. Another Antares variant now being retired. This is the last one to have Russian and Ukrainian components on board, and in a couple years we will see the introduction of the Antares 330 variant, which will have an all-new American first stage as well as American engines, also increasing its power and performance. If it's your first time here, though, welcome here at the launch pad. It's our mission to inform and inspire the explorers of tomorrow because we believe that space is better together. And if you haven't yet, take a moment, engage that subscribe button so you never miss another live launch coverage, space briefing, space news update, or exclusive one-on-one interview. NASA's just running through some of the payloads that are on board for today's mission that are heading up to the International Space Station. As we said a little bit earlier ago, space station docking expected about 2 days from now on Wednesday, November 9th. Capture expected around 5 a.m. Eastern Time. We'll be going live right about 3 a.m. Eastern Time to prepare for that final rendezvous and capture. If you guys have questions, you can send those in the chat by taking us at the launch pad, and we'll work on answering those. Let's listen back in to NASA Mission Control.
And LC confirmed new T0 is 103242.
Sounds like we might be having a change in the clock.
103242 is our new T0. And LD, do you copy?
Say again, LC.
Do you copy the new T0?
Yes, I copy. Thank you.
Step 397.
Can I get flight assurance and safety and GSO anomaly 1?
Flight control teams are taking a look at the Antares' onboard systems and plan to go into a 5-minute hold at the L-11-minute mark at 4:16:43, which would lead us to a new T-0 time of 4:32:42 Central Time towards the end of the launch window.
Copy, LC in work.
And we're just going to wait for NASA to roll out that new T0 again here. And we'll resync our clocks. Incredible live view there, close up. Still running that L-15-minute clock. But there will be a short hold, bringing them to closer to the end of their window ahead of their actual launch.
Go ahead, Core 1.
Step 399, fuel adjustment is not required.
Copy that, Core 1. And Prop 2, ARM OCCS for no adjustment to fuel level.
And LC, Prop 2, OCCS, ACDC is armed.
ACDC confirmed.
So we're heading into the final stretch of the launch countdown, again with a planned hold at L-11 minutes. We do have a guest from Northrop Grumman with us here today, Christina Halona. Thank you for joining us not only yesterday, but today as well. Christina, do we have you?
Hi, Chelsea. Yes, you do have me. Thank you. It feels good to be back again. And I just want to thank you all who are joining us live to see a successful Antares launch and Cygnus mission to the International Space Station. And once again, as a Navajo woman, I'd like to wish you all a happy Native American Heritage Month as well.
Christina, that's great. So launch is now set for 4:32 a.m. Central Time towards the end of the window. Can you tell us about some of the milestones we can expect going up to countdown?
Sure. So there's still some pre-launch milestones that are left. Right now, we are currently at the tail end of the propellant loading operations. When that is complete, the team will top off the propellant and do some fuel adjustments. Then you'll hear a final go, no-go poll that you'll hear here soon. That will be completed to proceed with the final countdown to launch. And then at about 3 minutes before launch, the auto sequencer will be initiated. This is where Antares' internal flight computer takes over and commands the vehicle. So the auto sequencer then goes through the final steps of prepping the vehicle for launch, and then we will proceed through the final countdown.
And Ops 1 and LCP advised, I'm going to go ahead and forward these steps to both of you again.
And Christina, what about post-liftoff? What milestones should we expect for the Antares rocket?
For Antares, the first milestone comes after the main engines burn for approximately 200 seconds and until main engine cutoff, which we'll hear on the nets as MECO. After MECO, we'll go into a short coast right before we separate stage 1 from stage 2, which we call the upper stack of the Antares vehicle. We'll continue then to coast for about 30 seconds or so before fairing separation, and then we will have an internal separation where the stage 2 flies out of the external upper stack. Once stage 2 is clear of the upper stack, stage 2 ignites for about 2.5-minute burn or so, which puts Cygnus real close to the orbit, and then it'll coast to ensure everything is stable. Then Cygnus will be released into the desired orbit. After Cygnus is released, it will go through some more comms checks. Then about an hour or hour and a half, we separate. Cygnus will release its solar arrays and be on its way to the ISS. So it takes Cygnus approximately 9 minutes or so to get to orbit.
Great, we're looking forward to it. And Christina, real fast, you had wished us a happy Native American Heritage Month. We just covered some of the science that's on board the SS Sally Ride, but something very special is also on board. Can you tell us a little bit about it?
Yes, and as you mentioned, the program names each Cygnus spacecraft in honor of substantial contributions to an individual with substantial contribution to the United States space program and human space flight. And the Engine 18 mission is proud to commemorate Dr. Sally Ride, who was the first female astronaut who served on the crew of the second flight of Challenger. She was definitely an advocate for diversity and equality in science, inspiring countless women and people of color to pursue STEM careers, including myself. And as an Indigenous woman from the Navajo Nation, Dr. Sally Ride was someone I aspired to be like, and she definitely paved the way for other women like myself to be part of the aerospace industry and to not be afraid to chase your dreams, which is very important. That is what Dr. Sally Ride continued to do until her death, to help inspire students, which brings me to the very special item. It is an American flag signed by all 402 students and staff from the Sally Ride Elementary School in Los Angeles, California, which was named by the neighborhood in Dr. Ride's honor. The school is 95% Hispanic and 5% people of color, and its vision and mission is the heart of Dr. Sally Ride's legacy.
It's wonderful to hear. Christina, thank you so much for joining us.
Thank you.
We're now in the 5-minute hold. As Christina said, there's many milestones that we'll be looking out for after launch. The first is main engine cutoff, also known as MECO, of the Antares first stage, about 3 minutes and 18 seconds after launch. About 6 seconds later, the first stage separates, so the first stage engine is turned off, it did its job, and the stage is discarded. About 30 seconds later, the fairing will separate. This is the shell that surrounds the Cygnus spacecraft during launch.
LC, this is CMD, step 410. Cygnus is in launch mode and nominal.
Copy that, CMD. Check step 404.
LC, TD, we're green.
LC copies.
LC, this is LD, proceed.
Ops 2, initiate evacuation of fuel cavities.
In work.
And opening VVP on my mark. 3, 2, 1, mark. 10, 20, 19.
You're getting a live view of Northrop Grumman's flight control room. These folks are going to take control of Cygnus after spacecraft separation. They're keeping in constant communication with Mission Control in Houston and also the Range Control Center at NASA's Wallops Flight Facility. This is where you'll hear a lot of the chatter as the countdown progresses. Will be from this room right here at the Range Control Center. They've got eyes on the launch pad, the range, as well as safety of the vehicle before it launches.
C copies.
LC, this is LD, proceed.
Ops 2, initiate evacuation of fuel cavities. At this time, I'd like to proceed with final countdown poll. GSO.
GSO, go.
RSO.
RSO, go.
TD.
TD's go.
Prop lead. Leaders go. Stage 1.
Stage 1 is go.
MES-1.
MES-1 is go.
GCE.
GC's go.
ACE.
ACE is go.
Mars.
Mars is go.
CMD.
CMD, go.
LD.
LD is go.
NG.
Northrop Grumman is proud to honor a renowned NASA astronaut and the first American woman in space, Dr. Sally Ride. Sally was a true space pioneer and also a tireless advocate for improving STEM literacy for children, especially young girls. Sally has inspired millions of students, and her legacy through Sally Ride Science continues to have enormous positive impact on STEM education across the nation. During her spaceflight missions, Sally was known to spend her free time gazing down at Earth. Hence, it is an honor to return her legacy to space to once again enjoy the view as the SS Sally Ride and Northrop Grumman are go for launch.
Go to proceed with final countdown. MES-1, do we have status on step 2?
LC, MES-1, evacuation verified.
And Ops 2, terminate engine evacuation.
And VVP is closed. 10, 22, 41.
And with 10 minutes planned until the T-0 mark of 4:32:42 a.m. Central Time, the team has polled their go for launch.
Opening VZD on my mark, and 3, 2, 1, mark. 10, 23, 03.
And ACE, LC on countdown 1.
Go ahead, LC.
Yeah, steps 405 and 406 still not required?
Stand by.
Going back to some of the launch milestones that we're looking forward to today, as Christina was talking about, we were first looking for main engine cutoff, or MECO, followed quickly after by first stage separation. After that, the fairing will separate, exposing Cygnus, although it has not reached orbit yet at this stage. The second stage of Antares, a solid rocket motor, ignites for 4 minutes and 7 seconds into the flight. At this point, Cygnus will be 73 miles in altitude, and it'll burn for almost 3 minutes before stage 2 burnout, putting Cygnus into its initial orbit.
LC Elec 1, ACS VDMs enabled, voltage nominal, ODM commands.
Then we'll look for payload separation, also known as spacecraft separation, meaning Cygnus is no longer attached to the spent second stage and is flying free to catch up to the International Space Station. All in all, it'll take 9 minutes from the time of launch for Cygnus to reach this point.
Copy.
Is that a copy or confirm?
Concur.
Our coverage will end shortly after spacecraft separation, but Cygnus will begin to deploy its round solar arrays about an hour and a half into its mission, or around 6:24 a.m. Central Time, around there. It'll complete its solar array deployment about 30 minutes later. We won't be in live coverage at this time, but be sure to look out for confirmation of the completion of solar array deployment on the blog and on social media.
GNC-1 provides status of trajectory file for launch operation.
Are you ready for me to deactivate VCD?
LCGNC-1, trajectory file is go.
LCMES-1 on countdown.
VCD closed.
Sorry, GNC-1, you got stepped on.
LCGNC-1, no trajectory file change is required. Trajectory file 1 is good.
Copy that. 408, not required. 409, not required. CMD report status of Cygnus.
BRG deactivated.
LCMES-1 on countdown.
LCCMD good. Cygnus good. LCOps 2 steps through Oscar 8 complete.
Copy that. Oscar 8 complete. Ops 2 405, initiate fuel inlet valve position override.
Didn't work.
The astronauts aboard the space station are awake and well into their day, and they do have live views of this launch available to them. NASA astronauts Nicole Mann and Josh Cassada have been preparing for Cygnus's arrival all week. They've been reviewing and practicing their robotic capture maneuvers on a computer to simulate what it'll be like when the real spacecraft arrives in just 2 days. Cygnus will make an automated approach until it's about 30 feet from the station. Then Nicole Mann will command the robotic arm to capture Cygnus from the robotics workstation in the cupola, while Josh Cassada acts as her second set of eyes to monitor the approach.
ACE LC on countdown 1.
Go ahead, LC.
Are 412 and 413 no longer required?
412 not required, 413 not required.
LCMES-2, fuel inlet valve position override status confirmed.
Copy 406 complete. And prop lead, I got your call on 418. Ops 2 initialize ground ordnance power supplies.
Ground ordnance power supplies initialized.
Ground ordnance power supplies nominal. And 422 is not required.
Ops 2 copies.
Ops 1, transfer avionics to internal power.
In work.
This chatter that you're hearing is coming from the Range Control Center at NASA's Wallops flight facility as they move through their countdown. You can think of it as mission control for the rocket before it leaves the ground. They're monitoring the procedures leading up to launch, which you're hearing now, monitoring weather systems, aircraft in the area, and are monitoring the safety of the situation in the unlikely event that the rocket veers off course or is acting off nominally. Another set of eyes. They're working really closely with the Cygnus Flight Control Center in Dulles, Virginia, as well as Mission Control here in Houston, under the direction of Flight Director Adi Boulos.
LC Elect 1, SNAs, ODMs, all armed. NASA TD, report range status.
Range is green.
And MES-1, can you confirm engine priming status is verified?
It is verified.
Step 431 is not required. Phase 3 dynamic limits will be active at T-minus 3 minutes. And launch team, despite regulators, alarm clocks, and desiccant dryers running amok, we are on schedule. FC commanded to flight mode. Auto sequence startup.
Just under 3 minutes until launch, and everything is go for launch.
Podium left voltage and current nominal.
Ops 2, switch to GNC1, verify ready for nav mode.
LC, GNC1, or nav ready for nav.
Ops 2, switch to nav.
LC Ops 2, switched to nav.
LC, GNC1, orb nav telemetry verified.
The teams opted to move to the end half of the 5-minute launch window with a new T-0 time of 4:32:42 a.m. Central Time.
Mark. T-minus 1 minute, 30 seconds.
We're well into the terminal count with T-minus 60 seconds and counting.
T-minus 30 seconds. Godspeed, Doug Harvey. T-minus 10. 5, 4, 3, 2, 1. Engine ignition.
We have liftoff. The Antares NG-18 launch vehicle on flight.
We have liftoff of Northrop Grumman's 18th Commercial Resupply Services mission. The SS Sally Ride has begun its journey to the International Space Station. The first stage is performing nominally so far.
Operating steadily at 100% thrust. Nominal. Or pressurization valves functioning as expected. Vehicle remains nominal.
One minute into the flight, no issues are being tracked with the Antares rocket.
We are passing through max Q. Vehicle remains nominal.
Antares is passing through max Q, the area of maximum dynamic pressure on the rocket.
Power remains nominal. Passing through 50,000 feet. Attitude remains nominal. Passing through 5,000 feet per second. Core pressurization valves continue to function as expected. Engines remain nominal at 100% thrust. Approximately 100 seconds to MECO. Passing through 100,000 feet. Power remains nominal.
Now at the 2-minute mark, everything is going as planned. You're hearing the Wallops Range Control Center reporting a good flight of the Antares rocket.
Vehicle attitude remains nominal. Nominal attitude. Core pressurization valves continue to function nominally. We have begun slow throttle down.
Throttle down is the precursor to main engine cutoff. MECO occurs at the 3-minute 18-second mark of the flight, followed right after by first stage separation. Coming up at the 3-minute mark, just seconds away from main engine cutoff.
And main engine cutoff. Stage 1 separation.
First stage separation confirmed from Wallops' Range Control Center, just as planned, about 6 seconds after main engine cutoff. Less than 20 seconds to go until fairing separation to unveil the Cygnus cargo spacecraft.
Good engine performance on stage 1. Stage 2 ignition in approximately 10 seconds. We have fairing separation.
Fairing separation is confirmed. Cygnus is now outside of its protective shell and is continuing to climb into its preliminary orbit.
And we have stage 2 ignition.
And with stage 2 ignition, the second stage engine will burn for about 2 minutes, 46 seconds.
The stage 2 Caster 30 XL motor will burn for approximately 2.5 minutes. Attitude remains nominal. Stage 2 TVC is nominal. Electrical power remains nominal. Attitude is nominal.
Coming up on the 5-minute mark of the flight, with second stage burnout expected at the 6-minute 53-second mark of the flight. At the time of second stage burnout and orbital insertion, Cygnus will be at an orbital altitude of 109.5 miles or 176.2 kilometers.
Attitude remains nominal. Stage 2 TVC is nominal power. Attitude remains nominal. Approximately 60 seconds remaining in stage 2 burn. Attitude remains nominal.
6 minutes into the flight of Northrop Grumman's Antares rocket, under a minute now until stage 2 burnout and orbital insertion.
Vehicle attitude remains nominal through stage 2 burn. Stage 2 TVC is nominal.
Coming up on stage 2 burnout.
We have stage 2 burnout. Beginning reorientation for payload separation. We have good insertion. Antares is currently in orbit and will
coast for approximately 100 seconds prior to payload separation.
Cygnus has reached its preliminary orbit insertion. Next, we'll be looking for Cygnus to separate from the second stage, which will occur at 8 minutes and 52 seconds after liftoff, about 2 minutes from now.
Antares power remains nominal during this coast.
We're continuing to hear good callouts across the board. Everything is nominal at this stage of the flight.
Approximately 60 seconds from payload separation. Vehicle attitude remains nominal. Vehicle power remains nominal.
Now, 8 minutes into the flight, Antares continues to perform nominally to put the SS Sally Ride Cygnus on its way to the International Space Station. Spacecraft separation is expected in less than 1 minute.
Power remains nominal. Approximately 30 seconds from payload separation. Antares remains nominal. And we have payload separation of the Cygnus spacecraft.
Spacecraft separation is confirmed. Antares launched at 4:32:42 a.m. Central Time, 5:32 a.m. Eastern, at the end half of the launch window. At the time of launch, the International Space Station was flying over the Indian Ocean southwest of Australia.
Okay, launch team, let's maintain our discipline, close out the pad, proceed with our post-launch checklist. Step 448, Prop 1. Could you give status on pulse purging?
LC Prop 1, first helium pulse purging cycle is complete.
You can see some celebration from the Range Control Center at NASA's Wallops Flight Facility. Cygnus has successfully separated from the second stage of the Antares rocket, and at this time, operations of the vehicle will move to Dulles, Virginia, under the direction of Northrop Grumman's Cygnus flight controllers. The SS Sally Ride has successfully moved through its milestones to get it into its preliminary orbit. It will spend the next 2 days catching up with the space station for a rendezvous and capture, followed by the installation of the vehicle to the Earth-facing port on the Unity module. You're looking at a live view of the Cygnus flight control room in Dulles, Virginia. This team is diligently working as they now have control of the Cygnus spacecraft now that it is in its preliminary orbit and separated from the Antares rocket. If you're just joining us, Northrop Grumman's 18th Commercial Resupply Services mission just launched from Launch Pad 0A at the Mid-Atlantic Regional Spaceport, part of NASA's Wallops Flight Facility. Cygnus is carrying 8,200 pounds of scientific experiments, food, hardware, and supplies to the people living aboard the International Space Station. We highlighted a couple of the scientific experiments on board, but this Cygnus is also carrying a number of tools as well as hardware that our spacewalkers might use in future spacewalks. You can get a breakdown of what's on board now. Joining me here today to talk a little bit about the space station and this resupply mission is Jeff Arendt, manager of the Systems Engineering and Integration Office in the International Space Station Program. Jeff, do we have you?
Loud and clear. Good morning, Kelsey.
Good morning. So Jeff, this kicks off an extremely busy period for the space station with a series of upcoming spacewalks. How will today's Cygnus launch support those operations?
Well, first off, I have to say it was a spectacular launch, and I want to congratulate the entire team from Northrop Grumman with their Cygnus and Antares teams to the spaceport, to the cargo mission contract team who packed the cargo, and the NASA team supporting this mission. Definitely a gorgeous launch, and we're happy that Cygnus is on its way to the ISS. As you mentioned, Cygnus is carrying some important spacewalk hardware. One critical set of hardware is what we call a mod kit, which is a collection of brackets that the crew will install outside while on the spacewalk that's currently planned for November 15th. The crew will partially assemble it inside, just hold on a second here, inside, and then they will take it through the airlock and install it at the base of a solar array wing so that it can be a support structure for a future set of rollout solar arrays. So there's direct support of the spacewalk with the hardware they will use, but there's also some indirect support. Cygnus will be bringing up some food treats for the crew, so indirectly supporting the operations with some much-deserved treats for the crew. They will have their usual menu, but they will also have some special requests like peanut butter, olives, several cheeses, and even pumpkin spice cappuccino. And the team has loaded some fresh fruit as well, apples, blueberries, oranges, and some ice cream in the freezers, chocolate and vanilla, and some of the special flavors that the crew has requested. So, good times.
Jeff, that sounds awesome. And you were just talking to us about the numerous U.S. and Russian spacewalks that are coming up before the end of the year. But that's not the only thing the flight controllers have their eye on in mission control. Can you tell us a little bit more about what's on the horizon for the rest of the year?
Yeah, absolutely, yeah. So for the next few weeks, the team will be very busy with visiting vehicle arrivals at ISS, science being conducted, and the 7 upcoming spacewalks. The arrival of NG-18, as well as a SpaceX mission later this month, will have the flight control team and the crew busy getting the space station in configuration for the berthing and docking and for the thousands of pounds of cargo transfers that the crew will be doing. We have a lot of science that needs activating and tending to quickly after it arrives. There are numerous payloads that fall into this category of needing immediate attention, U.S. payloads as well as international payloads from our European and Japanese colleagues. And with the 3 U.S. and 4 Russian spacewalks in the same time frame, the ground team is very carefully managing the crew's time. And it's really not that easy trying to juggle as many tasks as that we're planning to be doing. So a very busy time on the ground and on board. Having said that, we are hoping to be able to give the crew and much of the team the Thanksgiving holiday off. And back to the food theme, the crew will have holiday food available to help celebrate and take a short break. Also, something else this month we have is the Artemis mission. The targeted launch date is November 14th. And the teams are working to make sure ISS, SpaceX, and Artemis coordinate shared assets and can all complete our missions without issues.
So Cygnus is expected to arrive at the space station on Wednesday, November 9th, with a rendezvous and capture early in the morning. You were just talking to us about the crew members on board. Can you tell us a little about the milestones that we should expect for Nicole Mann and Josh Cassada?
Absolutely. So, but before that even, the Northrop Grumman team will deploy the Cygnus solar arrays and conduct a series of burns using Cygnus thrusters to get the vehicle closer to the station. The space station team will be getting ready as well, putting the ISS solar arrays in a good orientation for the Cygnus approach. Cygnus will arrive in the vicinity of ISS, and then it will go through a series of holds and what I call resumes to methodically get closer and closer to the station, and then it will remain steady for its capture. Astronaut Nicole Mann will be driving the Canadian arm for the capture, which is planned for at around 4:05 a.m. Central Time on Wednesday. She'll get assistance from Josh Cassada with cameras and procedures as she maneuvers the arm to reach out and grapple with Cygnus. The crew, of course, had ground training on monitoring the Cygnus as it approaches and with the Canadian arm operations. But the crew has also been preparing on board the station with simulations and actual movements of the arm in practice sessions. After capture, our ground control team will berth Cygnus to the Node 1 Unity module. And then after berthing, the crew will open the hatches, which should be done around noon Houston time on Wednesday. The team in space, as well as on the ground, have practiced all these activities and are ready to go.
Jeff Ahrens, thank you so much.
Yeah, appreciate it. Thank you.
So that's what this is all about, the continuous research contributions made in microgravity and assisting our astronauts who make it happen. We heard about some of the science on board. We heard about the mod kit launching on Cygnus for a November 15th spacewalk. And we even heard about the peanut butter and pumpkin spice cappuccino heading their way. To recap today's events, an Antares rocket launched from the Mid-Atlantic Regional Spaceport on Wallops Island, Virginia at 4:32 a.m. Central, 5:32 a.m. Eastern, towards the end of the launch window while the station was flying over the Indian Ocean. It brought the SS Sally Ride, a Cygnus cargo spacecraft out of Northrop Grumman, into its preliminary orbit. And while we won't cover this event live, the next major milestone for the spacecraft is to deploy its solar arrays. 2 days from now, on Wednesday, November 9th, Cygnus will arrive at the orbiting laboratory. Our coverage of rendezvous and capture begins at 2:30 a.m. Central Time. Cygnus is expected to be robotically captured at the controls of NASA astronaut Nicole Mann and Josh Cassada around 4:05 a.m. Central. We'll continue on with live coverage of its installation to the space station, a job conducted by robotics controllers here in Houston. These ground controllers will bolt Cygnus into place on the Earth-facing port of the Unity module. Throughout the week, the astronauts on the space station will work to unload the cargo, and Cygnus is expected to stay bolted to the space station for about 2.5 months, and until its departure, currently scheduled for January 2023. Thanks for joining. This is Mission Control.
And with that, the Cygnus spacecraft is on its way to the International Space Station. If you haven't yet, take a moment and engage that subscribe button so you never miss another live launch coverage, space briefing, space news update, or exclusive one-on-one interview. And we hope you'll join us back here in 2 days for final rendezvous, capture, and installation of the Cygnus cargo resupply. But for tonight, this is Zach from TLP Network Studios signing off. We'll see you next time. Bye-bye.